Greetings all. So, in the previous class, I had already covered the budget constraint chapter, but it was a pretty lengthy one, 45-46 minutes it consisted. So, I thought of taking another class with 15 minutes of videos, two videos. So, it will be easy for you guys to download the class. So, that's it. And here in the first video, first class, I'll be covering till how the budget line changes. So that is 4 topics, and in the next class I'll be covering the rest 3. The only reason for me to take the class in a single video the previous time was that there's a basic chapter. It is a very basic chapter, but downloading YouTube videos is an issue, so I thought of taking it again. So second chapter, budget constraint. So according to an economist, the consumer theory, economic theory of a consumer is very simple. Consumer chooses the best bundle of goods that he can afford. Here the words best and can afford have huge meanings in an economic perspective. This chapter is devoted to describe what a consumer can afford, and the next chapter, preferences, is to clarify the concept of how the consumer determines what is best. Okay, so budget constraint. Before budget constraint, we can start with a simple example. Like, suppose that we are given with a set of goods from which we can choose. So there will be many goods, no? In our real life, day-to-day life, we use many goods, we go through many goods. It is not convenient to include all in a budget set because for the calculation and analyzing it is not at all convenient. So here we use the two good theorem, where there will be only 2 goods in our consumption bundle, X1 and X2. So in our real life there are many goods, but for the convenience in this chapter, in economics, we use the two good theorem. Two-dimensional graph will be used here. So two good theorem, X1 and X2. And how will we include all the goods here within this two good bundle? So X1 will be specifically the good that the consumer is investing in or consuming, and X2 will be all other goods other than X1 where the consumer is ready to spend his money or consume. Okay, suppose X1 is milk. The consumer is ready to consume, is interested, is willing to consume milk. So X1 is milk, and X2 will be all other goods other than milk where the consumer is ready to spend his money. So that is composite good. That simply is composite good. So X2 can also be denoted as the money consumer is ready to spend in all other goods other than X1. Okay, as X1 is one specific good and X2 is all other goods other than X1 where the consumer is ready to spend money. So as X2 is not a specific good, we can say that it is the money, X2 denotes the money that the consumer is ready to spend on all other goods other than X1. That's it. So if the consumption bundles are having X1, X2, we can denote it in a single symbol abbreviation like capital X. Okay, so that's what mentioned here. It's not that simple. Just read it. And this is the budget constraint. P1 X1 plus P2 X2 lesser or equal to M. Okay, so P1 X1. So X1 and X2 are the goods. P1 is the price of X1, P2 is the price of X2. It will be lesser or equal to, the sum of both this will be lesser or equal to income of the consumer, which is denoted by M. Okay, and what if it is equal to, just equal to sign, that is if there is no lesser than sign here, it is just equal to M, then the budget line, then the concept of budget line comes. Okay, so if the consumption bundles expenditure exhaust that is the bundles of goods exhaust the consumer's income, they will be on the budget line. Okay, so we'll be studying on detail it in the next topic. So here it is about the prices and we studied that. And all the goods that comes in this P1 X1 plus P2 X2 which are lesser or equal to M are known as affordable consumption bundles. And the set of all these affordable consumption bundles are known as budget set. Okay, so these are the three terms we are going here: budget constraint, affordable consumption bundle, budget set. So just study the definitions of these three. Okay, it might be asked. So next is two goods are often enough. So there is a two good theorem stating the composite theorem. Okay, so the same example I had explained it now, that is P1 X1 plus X2 lesser or equal to M. Why there is no P2? Because we said that P1 consider X1 as milk and X2 as all other goods other than milk where the consumer is ready to spend his money. So we can consider X2 as the money. In other words, we can say not as all other goods other than X1, but as the money that the consumer is ready to spend in all other goods other than X1. Right? So X2 denotes the money that the consumer is ready to spend in all other goods other than X1. So there is no need of P2 here, because P2 will be 1. Automatically P2 then will be 1, because X2 already denotes the price. So that is composite good. Composite good is a good that stands for everything else other than the consumer might want to consume, other than good 1. So it can be measured in price also, that is dollars or rupees or whatever. So P2 will automatically be 1 in the budget constraint when it is a composite good interpretation. Next is properties of a budget set. So budget set we studied, set of all the affordable consumption bundles. Affordable consumption bundles means P1 X1 plus P2 X2 lesser or equal to M. So when it is equal to M, that will lies in the budget line. This is the budget line. Okay, I'll denote this. This is the, oh god, my line is so pathetic. Anyway, this is the budget line. So P1 X1 plus P2 X2, such bundles will be on this line, and all which are lesser than M will lies in this line. I mean this part, this shadowed region. Okay. Next, so this M by P2 and M by P1, how those are denoted. So the horizontal and vertical intercepts measure how much the consumer could get if she spent all of her money on good 1 and good 2 respectively. So in order to depict the budget line, just plot these 2 points on the appropriate axis of the graph and connect them with the straight line. M by P2 here and M by P1 here. So this is the X2. So this is where the X2 is denoted, and the price of X2 is P2. So if the bundle is here, it means 0 amount of X1. That is, the consumer is not at all spending a penny in X2. Sorry, X1. He is not ready to consume X1. He just want X2. So all his income will be spent to X2. That is M by P2. Here also applies the same thing. So this is what M by P2 and M by P1 are. Budget set, we have gone through that. Now we can arrange the budget line in equation. Okay, so this is how we can arrange this. P1 X1 plus P2 X2 is equal to M. We know the budget line equation. Then P2 X2 is equal to M minus P1 X1. We are taking this to the other side. Then we are taking P2 to this side, so it have to be divided with both. That is M by P2 minus P1 x1 by P2. So what does this formula tells? First of all, we got minus P1 by P2 is the slope of this straight line. Okay, so the budget line is a straight line, but the vertical intercept is M by P2. And this formula tells us how many units of good 2, that is x2, the consumer needs to consume. The result here is x2. So how much more x2? Here we will get how much more x2 is to be consumed to satisfy the budget constraint if the input, if she is consuming x1 units of good 1. Okay, that's it. And next, this is about drawing this budget line. Oh, we have, no, just read it. There is nothing more in that. Next, it is about the slope of the budget line. Okay, so it is having a nice economic interpretation. So what does it measures? It measures the rate at which the market is willing to substitute good 1 for good 2. We all know what a slope is. It denotes the change. And what is the change here? Rate at which the market is willing to substitute good 1 for good 2. So as in this formula, we are studying how much more x2 is to be consumed to satisfy the budget constraint when x1 units of good 1 are consumed. Okay, so the rate of substitution, like if x2 is this much, if x1 is this much, how much more x2 have to be, or how much less x2 have to be consumed? The change in x2 that have to be brought to satisfy the budget constraint. Okay, so that is what the slope is for. Suppose, for example, that the consumer is going to increase her consumption of good 1 by delta x1. How much will her consumption of good 2 have to change in order to satisfy her budget constraint? Okay, so the change in good 2 we can denote for time being it as delta x2. Okay, so we know what the budget line equation is. It is P1 x1 plus P2 x2 is equal to M. So x1 has changed. In the question it is said that delta x1, added delta x1. Delta means the change. It can be minus or plus, whatever it can. So it's just mentioned as delta x1 plus P2 x2 plus delta x2. For the time being, we represented the change in good 2 as delta x2. So here comes the second equation, and we subtract the first equation from this. We'll get P1 delta x1 plus P2 delta x2 is equal to 0. So it says that the total value of the change in the consumption must be 0 to satisfy the budget constraint. Okay, how this comes 0? That is very easy, right? Okay, P1 x1 plus P1 delta x1, P2 x2 plus P2 delta x2 is equal to M. So subtracting P1 x1 will get cut. P2 x2 will also get cut. M minus M is 0. Then P1 delta x1 plus P2 delta x2 is equal to 0. And solving for delta x2 by delta x1, what we'll get? Minus P1 by P2. This is also very simple. You just, it's the mathematical steps. 2 or 3 basic mathematical steps will take you to this part. Okay. So this is just the slope of the budget line. The negative sign is there since delta x1 and x2 must always have opposite signs. When you gain one, you need to sacrifice the other. That is the opportunity cost. So it is because of this opportunity cost we are having a negative slope. Slope of the budget line is negative. In order to consume more of good 1, you have to give up some consumptions of good 2. That is, when you gain, you also need to sacrifice. Next is how the budget line changes. With this, concluding this class. So it is very easy. I'll just take the graph and see. So if your income is increased, change in income. First we can talk of change in income. The impact brought by change in income in a graph. So here I'll, at this particular point, M1, the first income is 50 and price are 10, price of good 2, price of good 1 is 10 and price of good 2 is 5. Let's make it simple. So here it will be M by P1 will be 5, so 5 units of good 1 can be purchased, or in this income the consumer can purchase 10 units of good 2. Okay, but when his income increased, so the new income is 100, prices are the same, there is no change in the price, then how many goods of X1 can he purchase? 100 by 10, that is 10 goods he can purchase. Then for X2 he can purchase 100 by 5, 20 goods. Okay, 20 goods. So what happened here is a parallel shift. When the income increased, it brought a parallel shift for the this budget line. When it is decreased, vice versa, it will bring a parallel inward shift. Okay, so when the income is increased, parallel outward shift, and when the income is decreased, parallel inward shift. So that is about the change in income, the change brought by change in income. Next is the change brought by change in the prices of the goods. Okay, when the prices decreased of good 1, we are speaking first the case of good 1. When the price of good 1 is decreased from P1 to P1 prime, for example 10 to 5, okay, the budget line will be steeper. How it will be steeper? Because consider the income as 50. Here the consumer can have, when it was 10 rupees, he can have 5 units, and here he can have 10 units. So this will be steeper. And when the price is increased, it will be flatter. Okay, so that is the case with good 1, and same applies for good 2. When the price is increased, it will make the budget line more steeper. When the price is decreased, it will make the budget line more flatter. So this is the first price, A and B. So this is a decreased price, so the budget line will be like this, and when the price was increased, the budget line will be like this. So this is steeper and this is flatter. That's it. Next is what happens to the budget line when we change the prices of good 1 and good 2 at the same time. Okay. Suppose, for example, we double the prices of both good 1 and good 2. In this case, both the horizontal and vertical intercepts shift inward by a factor of 1/2. Therefore, the budget line shifts inward by 1/2 as well. Multiplying both prices by 2 is just like dividing income by 2. For example, so this is the budget line and we are multiplying both the prices. Both the prices are changing at the same time by t. So t p1x1 plus t p2x2. So t can be taken in bracket outside. Then the t will, the other side of this equation, it will be on division, so m by t. So multiplying both prices by a constant amount t is just like dividing the income by the same constant t, and this is called as balanced inflation. Okay. So here the budget line won't change. Next, we can also consider price and income changes together. What happens if both prices go up and income goes down? Then the horizontal and vertical intercepts, like if m decreases, income decreases, and p1 and p2 both increase, prices of the goods increase, then the intercepts m by p1 and m by p2 both decrease. Okay, this means that the budget line will shift inward. And about the slope of the budget line, if price 2 increases more than price 1, it will be minus p1 by p2, like it will decrease. Then the budget line will be flatter. If price 2 increases lesser than price 1, the budget line will be steeper. So next we'll cover in the next chapter. Okay. I mean next class. Okay, it is very simple, numeraire, just pegging things to 1. So anyway, I'll cover it in the next class. Bye.